All right, in this one I'm going to be going from 41 and on, however far I make it. So 41, we have to use long division to divide this by this. So notice in my division I have what I'm dividing by, what I'm dividing on the inside, and what I'm dividing by on the outside, this x squared plus 3 right there. Then it's a matter of x squared times what is 6x to the third. Well, x squared times 6x is the same thing as 6x to the third. So I do 6x times x squared is 6x cubed. 6x times 3 is 18x. And then don't forget, just like regular division, you have to subtract this line. So I went through and I subtracted, I brought down what I had left over. So I have 2x squared, 18, negative 18 makes 0, and I have 25. So then again, it's what times x squared gives us 2x squared. Well, that would be 2, so multiply the 2, you come out with 2x squared and 6, change your signs. You have this as your remainder. So it's saying, what is the quotient, what is the remainder? The quotient is just this 6x plus 2 part. The remainder is this 19, and I usually put it over what I'm still dividing by, just like we do in regular long division. All right, number 42, it says divide this by this. As long as we're dividing by something linear, we can use synthetic division. Remember, synthetic division is kind of upside down. On the inside, I put the coefficients of what I'm dividing. On the outside, I put the 0 of what I'm dividing by. Then I bring down the 2. 2 times negative 4 is negative 8. Negative 3 and negative 8 together make negative 11. Times negative 4 is 44. 2 and 44 make 46. Times negative 4 is negative 184. That makes negative 188. So this is saying, I started with 2x to the third. I brought out an x, so I have 2x squared now. Minus 11x, I'm just carrying the coefficients right here, plus 46, and then I have a remainder of 188 over what I'm still dividing by. All right, 43. Is it a factor of this? So if it's a factor, my remainder will be 0 when I do synthetic division. It is indeed 0 when I do synthetic division, right as a product of two factors. So I had this factor, x minus 1, and then I also have what I have left over, so x squared plus 5x minus 2, x squared plus 5x minus 2. Just be careful, that looks like it's the same thing, but it has that x plus 1 there. We had the 0 of what we were dividing by on the outside, so that is why I need x minus 1 there. Number 44, divide using synthetic division. Let me zoom in just a little bit. Zoom, zoom, zoom. So again, same thing as we were doing on number 42. You put the 0 of what you're dividing by on the outside, the coefficients of what you are dividing on the inside, bring everything down. 16x squared minus 12x minus 1. All right, moving on. For 45, zoom out just a little bit. Dang, that's too big. Hey, that's zoomed in. Come on. Come on, man. Stop it. The heck? Gosh, I'm pressing the right buttons. You're not doing it, stupid technology. So we have x cubed plus 3. So again, you can just type this in your calculator, match which one it looks like. This is the only one I know plus 3 moves our cubic function up 3. So from 0, I move my cubic function up 3. That's the only one that moves up 3. That's my answer. Done. Cubic function, move to the right 1. That moved down 1. That moved up 1. That moved left 1. That moved right 1. So that's my answer. That's the only option I have here. Here I have what is the y-intercept of a function that is graph shifting blah, 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 down 8 units, cube root of x. So I know my cube root normally looks like this, where my y-intercept is 0. If I shift it down 8 units, that is not the right answer, because I'm going down 8 units. Come on, pencil, work for me. So I'm going to negative 8. So it's going down 8, so I should be at 0, negative 8 for my y-intercept, where I'm crossing the y-axis. All right, 48. Getting there, getting there, getting there. So I have, that would be left 2. So I have a cubic left 2. So I have a cubic left 2. This one is right 2, this one is down 2, this one is up 2. This is the only one that moves to the left 2. Moving on. Cubic multiplied by 3, right 2, up 1. So if I just look for the right 2, up 1, I have right 2, up 1 right here. I have right 2, up 1 right there. I have right 2, down 1 there, so that's not it. That's not even a cubic function. Or sorry, cube root. I keep saying cubic. Cube root. But now, since it is a positive 3 on the outside, it's not flipped or anything like that. This would be if we had a negative coefficient. So that does not work, so C is my only option there. Again, you can type this stuff in your calculator and check it. Here, determine what graphs are g of x and f of x. So notice f of x is 2 to the x. So 2 to the x is not going to grow as fast as 10 to the x. So it's really kind of close as to what these things are. So for f of x, I have 2 to the x, so if I plug in 1, I should be at 2. So f of x, if I plug in 1, I should be at 2. I actually chose the wrong one. I'm sorry. It's now right. So when I plug in 1, it should be at 2. For g of x, when I plug in 1, I should be at 10. G of x1, this is not at 10. That should be there. So this is actually a. But again, pay attention to where f of x and g of x are, because these are very closely related, except for notice the names are kind of switched around. All right, for number 51, graph the function 2 to the x minus 4. This is just an exponential function, kind of like what we have up here, move down 4. Again, you can put that in your calculator and graph. Determine the x-intercept. So if we have an x-intercept, the y is 0, so I set the y equal to 0, and then I'm going to solve this thing. I add 4 to the other side. Well, 2 squared is 4, so x must be 2, so therefore my x-intercept is 2, 0. Beautiful. The asymptote, how is it affected? The asymptote of e to the x looks like that, and the asymptote is at y equals 0. So this is moving everything to the right 3. If it moves it to the right 3, we're not moving up and down, so it doesn't really change. I mean, it's to the right 3, but to me, there's two answers. It doesn't really move. It moves to the right 3, yes, but it's also still the same line, y equals 0. So whatever you put there, I'll make sure that I check that. Give an example of an equation that will translate right 5 units. Remember, you need to put it with the x, and it needs to be the opposite when we are with the x. Determine log form. So log base 2 of 32 equals 5. The base is the base. It equals the exponent, and then a number is what we are taking the log of. So it's a base exponent equals the exponent. So the way that I see this, you have 2 and 5 together in this form. They do not go together in this form again. So I have log base 2 of 32 equals 5. All right, I'm going to stop this one. I'm going to make another one.